the cardinality, or you can say the number of that event, or the cardinality over the sample space, or let me go and put total. So once you know this rule, then it is going to be easy for you to do. Now, in this case, what is our total? Our total number of balls or marbles is, we have 3 yellows, 7 black, and 5 white marbles. So here in total we have 15 marbles. So what is the probability of drawing a black marble? The probability of drawing a black marble is going to be the number of black marbles over the total number of marbles. So how many black marbles do we have? Here we can see that we have 7 black marbles over the total, which is 15. This rule is general for any problem you can come across in probability. Now let's move to question number 2. In question number 2, it says, if you roll a standard 6-sided die, what is the probability of rolling even number? The first thing you have to do is to get the total sample space. When you throw a die, the possible outcomes are 1, 2, 3, 4, 5, and 6, right? This is the possible sample space you can have. So the total is what? 6 faces. Now, what is the probability of throwing even numbers? So here we have the cardinality, or the number of even numbers over total. So here, what are the even numbers we have? The even numbers are numbers that can be easily divided by 2. So here we're going to have 2, 4, and 6. So in total, we have 3 even numbers over the total, which is what? 6. Finally, your answer can be in 1 over 2, which is half. Question number 3. It says, in a jar, there are 6 yellow, 4 blue, and 5 green marbles. If a yellow marble is drawn first and not replaced, look at this, it's very important. This is without replacement. What is the probability that the second marble drawn is a yellow? The total marble we have is 6 yellow plus 4 blue plus 5 green marbles. In total, we have 15 marbles. And here we have the number of yellow. We have 6. So the question is, find the probability that the second is yellow. Let me put that as y2. So we have that the second is yellow over the total. Now it says if a yellow marble is drawn first and not replaced. So in that case, since the first yellow marbles drawn was not replaced, that is, the second yellow is going to be 6 minus 1. Okay, because the first yellow was not replaced, so the number of yellow is going to be 5. And our total was initially 15. So the first marble was drawn and not replaced, so the total is going to decrease also by 1. So here we have 5 over 14. Question number 4. It says, in a bag, there are 5 black marbles, 6 white marbles, 3 red marbles, and 2 blue marbles. What is the probability of drawing either a black or a red marble in one attempt? Now here, the first thing to do is to get the total number of marbles. We have 5 black marbles plus 6 white plus 3 red plus 2 blue marbles. Here in total, here we have 16. Now the question now is, okay, here we are looking for the probability of selecting black or red. So for black marbles, the number of black is what? 5. And the number of red marbles, for red marbles, we have that to be 3. Now we want to calculate the probability of selecting a black or red. In probability, when we talk about OR, we use addition. When we use the operation AND, we use multiplication. Okay, now the probability of black or red. So the number of black or the number of red. So we have 5, or means plus 3 divided by the total, which is what? 16. So here we have 8 over 16, and here we have 1 over 2. Question number 5. It says, a bag holds 9 green, 2 purple, 6 red, and 3 blue marbles. It can be marbles, it can be balls, or any object. It can be orange. I'm just using marbles as an example here. What is the probability of randomly drawing either a green or a blue marble? So for the last one, I want you to pause for a few minutes and use the knowledge in question number 4 to do this. Pause this video for some minutes and do this video and do this question. Okay, I'm going to do the answer right now, and I want you to check if what you've done is the same thing with what I'm going to do. Now, the first thing you have to do is to get the total. For the total, we have 9 green, 2 purple, 6 red, 3 blue marbles. If you add this up, this is going to be 20. Now, it says, what is the probability of randomly drawing a green or a what? Or a blue marble? For the green, we have our green to be 9. And we have our blue to be 3. So the probability of drawing the green or blue, using the same approach, is just going to be the number of green or you can say or blue over total. So green is 9. I told you all means addition, plus 3 over 20. And this is going to be 12 over 20. You can divide this further if you want. 4 in 12 is going to be 3. 4 in 20 is going to be 5. So your answer is going to be 3 over 5. So I'm going to stop here on probability. In my next video, I'm going to move to another topic. If you have any questions on probability, put it in the comment section. Thank you very much. See you next time. Bye. Hello viewers, in this example, I want to use TI-84 calculator to solve questions on binary distribution. Now let me look at the example. It says a survey finds that 12% of adults have a fear of flying. From this, we can see that our probability, which is the probability of success, is 12%. Okay, which is equivalent to saying 0.12. If a random sample of 30 adults is selected, this shows that we have our sample size n to be 30. find the following. So the first question is telling us to find the probability that exactly 4 are afraid of flying. This means we have the probability that exactly 4 adults are afraid of flying. And to do this using the TI-84 calculator, we use the command which is binom. Binom is standing for binomial. PDF, the probability density function. Then you have the N, you have the P, and we have the K. So this is what we're using. So to use MPK, we have binom. In this case, N is 30, P is 0.12, and K, which is 4, which is the corresponding value of X. Now let's do that using the TI-84. To do that, you press the second button and distribution. After that, you come down here to binom PDF. Click on binom PDF. Here we have what is our trial. The trials is the sample size, which is N, and we have the value of 30. And also we have the P, which is the probability of success, which is 0.12. And we have the X value. Our X value in this case is 4. Paste. So this is binom PDF MPK, and you can click on enter. So the probability is 0.2047 approximately. Secondly, we have find the probability that at most 4 are afraid of flying. In statistics, every time you see the word at most, it's talking about the maximum value. You can see is the maximum. So the probability of at most means X is less or equals to 4. So it cannot exceed 4. And to do that, it means we need the cumulative from when X is 0 to when X is 4. So here we have the binom CDF. In this case, for at most, we are using the CDF and not the PDF. NPK. So which is the same thing as saying we have binom CDF. N is 30, P is 0.12, and K is 4. So let's do the same using our TI-84. So press the second button, the distribution. Then here you can come down to binom CDF, which is below binom PDF. Click on enter. So plug in the number of trials, which is 30, the probability, which is 0.12, and also the X value, which is 4. And you can paste. Click on enter. So the probability that at most 4 will be afraid is 0.7118 approximately. You can see that we have higher probability in this case. And lastly, this question says, find the probability that at least 2 are afraid of flying. At least means the minimum you can have is 2. So to do that, we have that the probability of X is greater or equals to 2. It can be 2 or more than 2, which is the same thing as saying 1 minus the probability that our X is less than 2. Yes. Which translates to saying 1 minus binom CDF N P K minus 1. Here we have K minus 1 because it is less than 2, not equals to 2. So here we have 1 minus binom CDF N is 30, P is 0.12, and K minus 1 is 2 minus 1, which is the same thing as 1. Now using the calculator here, we have second, distribution, then you can come to binom CDF, plugin. So number of trials is 30, P is 0.12, but here the X value is going to be 1. So here we have 1 minus 0.10997. So by doing this, we have 1. From here we can have 1 minus answer. And finally, we have the probability of at least 2 to be 0.8900. Thank you very much for watching. If you find this very insightful and helpful, kindly subscribe. In this video, I would like to explain how to use the TI-84 calculator to get the least squares regression line. This example focuses on the relationship between the age of the car and the selling price. So in this example, our age of the car is going to be our input and the selling price is going to be the output. Now on the TI-84 calculator, you click on Start, Edit, then you can plug in the information. So the L1 is going to be the input, which is this, and the Y is going to be the output, which is going to be L2. Now let's plug in the information. Here we have L1 to be 1, 2, 3, 4, 5, 6, 7, and 8. And also for the L2, we have that to be 28, 24, 22, 19, 16, 14, 12, and 9. Then the next thing to do is to get a regression line. Don't forget that a regression line is of the form y equals to a plus bx. The b is the slope. The a is our intercept, or otherwise you can call it the constant. The x is the input. So the x will be used for the prediction, and the y is going to be the output, which is the same thing as our response. Now we want to get the regression line using the format. We click on Start, then click on Calculate. Come down to number 8, which is Line Reg, a plus bx. If you look at this, a plus bx is the same thing as this format, but if you click on number 4, it is different format entirely, but it's still the same, but it's quite different. So don't click on number 4, click on number 8. Then X list is going to be the L1, the Y list is going to be the L2. Then we can calculate. Now here we have our A to be 29.7 and B to be negative 2.6. So the regression line is going to be 29.786 approximately minus 2.619x. This is the slope regression equation. This is the slope. This shows that the price will be decreasing anytime x is increasing. Alternatively, it means the increase in the number of years of the car will make what? Will give you the decrease in the selling price. So if you want to interpret this, means for every unit increase in the age of the car, then the price of the car will decrease by what? 2.619. Or alternatively, you can say 261.9%. So that is going to be the decrease in the price of the car. Thank you very much for watching. Please don't forget to subscribe. In this video, I would like to explain to you how to construct a scatter plot from a given data set. Now, in the data set we have here, we have the age of cars and the selling price. And we want to use the TI-84 calculator to construct the scatter plot. To construct the scatter plot here, we go to the start button, you click on the start button, then click on edit. Now we have two data sets, the age of cars. You can make the age to be L1 and the selling price to be L2. It doesn't matter which one is L1 or which one is L2. Now for the age of cars, you can plug in this information into L1. Now to plug in, here we have 1, 2, 3, 4, 5, 6, 7, and 8. And in L2, we want to plug in the value of the selling price, which is 28, 24, 22, 19, 16, 14, 12, and 9. So this is the value we've got. Now the next thing to do is to click on second function, start plots, and we can see the start plot done. Then you can click on the number 1. Here in your calculator it can be off or on, but make sure you click on on. Then under the type we have different design. This is for histogram, this is for the box plots, and these two. Then the first one is going to be more appropriate. On your X list, let it be L1 and Y list to be L2. For the mark, you can choose different design you want, but I think this is okay. Now next is to click on second quit. To plot the scatter plot, we click on the zoom button and you click on 9. Can you see how beautiful it is? Now looking at this, what can you say about this? The question says, would the slope of the line be positive or negative? Now let me tell you this. For a scatter plot, if your scatter plot goes down like this, this is negative. If the scatter plot goes up, this is positive relationship. So here in this case we have negative slope. So this is what we can deduce from this. And alternatively, you can see that as the value of L1 increases, the value of L2 increases. This is like inverse relationship. Now thank you very much for watching. See you next time. In this video, I'll be explaining how to perform some basic descriptive statistics using the TI-84 or 83. Now, we have this data set and we want to answer the following questions. To do that, the first thing you have to do is to click on the Start button. So after you click on the Start button, you click on the Edit. This is done to plug in the data set. Now we have the L1. You can plug in your data set in L1. So what are the data set that we have? Now we have 5. Then you click on enter. Let's plug in the data set. 8, 12, 14, 7, 10. 7, 10, 17, 19, 20, 6, 9, 14, 16, 12, 8, 7, and 10. So in total, we have 25 values. We have 24 values. Now to perform the descriptive statistics, we need to click on the Start button again. Then you come forward to calculate. Under the calculate, we have one VAR start. Why? Because we are having just a single variable, not two variables. If you are comparing two things, then you can click on two variable start. But in this case, we have only one variable. Click on that. The list is going to be L1. Why? Because we plug in the data set under L1. So you leave the list as L1. The frequency list, you can leave that and you come to calculate. But in a situation whereby you plug in your data in L2, make sure it is in L2. But in this case, we have it as L1. Then you click on calculate. Now here, question A says find the mean. the mean with the symbol X bar equals 11.32. And the second question says find the median. Now the median is the same thing as Q2. This is the median. You can see the median is 10. So we have the median to be equals to 10. And question B says that comment on the shape of the distribution. What is the shape of the distribution? In my previous video, I mentioned that if the mean is greater than the median, then we can say that it is right skewed. But if it is less than, then you can say that it is left skewed. And if they are approximately the same, it is symmetric. Question C says find the standard deviation. What I mean by the standard deviation here is the sample standard deviation. Now let's go back to the calculator. You can see S subscript X. This is the standard deviation for the sample. But if I'm interested in the population standard deviation, then it's going to be sigma X. But in this case, we are interested in the sample standard deviation. So my sample standard deviation is going to be 4.356. What about the variance? Don't forget the formula for calculating the variance equals to the standard deviation squared. So that is, you have 4.356 squared, and that should give like 17 point something. We can do that immediately after. Here we have 4.356 squared. So here we have this to be 18.9747, and you can leave it in 3 decimal place. So you can go back to the question and see your answers easily. The next question says that find the first and the third quartiles. The first and the third quartiles. The first quartile is the same thing as Q1. And what is our Q1? We have our Q1 to be 7.5. This is the first quartile. And our Q3 is the third quartile. Q3 is the third quartile, while the median is Q2. So the third quartile is 14.5. The next question says find the interquartile range. The interquartile range is represented as IQR with the formula Q3 minus Q1, which is 14.5 minus 7.5. And the answer here is 7. The next question says find the lower outlier boundary. For the lower outlier boundary, here we have the formula to be LOB to be equals to Q1 minus 1.5 IQR. This is the formula for the lower outlier boundary. Now to do this, we have the Q1 to be 7.5. Okay, we have our Q1 to be 7.5 minus 1.5 multiplied by the interquartile range, which is multiplied by 7. And this is going to give us 1.5 multiplied by 7 should be equals to 10.5. And 10.5 minus 7.5, this should be equals to negative 3. For the upper outlier boundary, we have our UOB to be equals to Q3 plus 1.5 IQR. And our Q3 in this case is 14.5 plus 1.5 multiplied by 7. And this should be 10.5 plus 14.5 plus 10.5, which should be 25. And if the case is, do we have any outliers? No, because none of the observation is greater than 25. So this is how to use TI-84 for the basic statistics. Thank you, and please don't forget to subscribe. In this video, I'll be explaining the numerical summaries of data, and what you want to learn in this video is how to use the measures of center, spread, and position. Yeah. Now, the measures of center, the first I'm going to talk about is the mean. What is the mean? The mean is the same thing as calculating the average of a data set. And the mean is affected by outliers. So it might not always represent the typical value. And how do we calculate the mean? For example, you can have something like A, B, C, and D as your data set. I'm going to provide an example in the subsequent slide. Then to count, you have to add the data set and divide it by the number of observation you have, which is going to be 1, 2, 3, 4. So this is the general method for calculating the mean. Secondly, we have the median. The median is the middle value in a sorted data set. So the first thing you have to do before you use the median is to sort your data set. It can be in decreasing order or in an increasing order. For example, you can have A, B, C, D, E. Then you look for the middle value, which is going to be C, and this is going to be your median. But in some cases, you can have it as even numbers, or you can have it as odd numbers. In this case, we are having this as odd numbers, which is 1, 2, 3, 4, 5. But in the case where you have it in form of middle number, like example, you have A, B, C, D, E, F. In this case, you are having these two numbers in the middle. So what you have to do is to calculate the average. In the subsequent example, you will see how this is being done. And the last one is called the mode. Another name for mode is the most occurrence, the most frequent value in a data set. That is the mode. If you look at these three measures of center, the median is not being affected by the extreme values. And here we talk about comparing the mean and the median. This can be used to define the shape of the distribution. Anytime your mean is greater than the median, then you can confidently say that your data set is skewed to the right. In the previous class, we talked about skewness to the right, skew to the left, and symmetric. When your mean is greater than the median, then you can say that the data is skewed to the right. If the value of the mean is less than the median, then you can say that the data is skewed to the left. And lastly, anytime your mean is approximately the same thing as the median, then we can say that this is symmetric. In the subsequent example, I will give you some data sets and I will ask you to find the shape of the distribution. Also, we talk about the measures of spread. Here, when you talk about the word spread, we are interested in talking about the variation. And here we talk about the range, the standard deviation, and also the variance. When we talk about the word range, range is the difference between the minimum and the maximum value. So range, the formula for range is the max value minus the minimum value. This is the formula for calculating the range. And also we have the standard deviation, in our next video, I'm going to give you an example on standard deviation. Easily, this can be done using the TI-83 or 84 calculator. Now we have this example. The cost price of a product for 10 randomly chosen days is reported as given. If you look at the data set is already sorted, which is in ascending order. Now the question is find the mean. And to find the mean, we have several notations to find the mean. The mean can be represented as x bar, which is the same thing as saying 1 over n summation of your xi, where your I is from 1 to n. And in this case, it means the addition of everything you have, which is 24 plus 25 plus 29 up to the last value, which is 40, dividing this by the number of data sets, which is 10. If you sum up the numerator, you should have 3317 over 10, which is the same thing as 31.7. The next one is find the median. Now to find the median, in this case, we need the middle value. And if you look at this data set, we have even numbers, which is 10. So the two middle values are going to be, okay, the 5th and the 6th value. Or alternatively, you can do it this way. Cancel out the first one, then you cancel out this. You cancel out the second one, and you cancel from behind too. You cancel out this, you cancel out this. You cancel out 29 and 35, then you can get the two middle values. And the median are going to be the average of those values, which is 30 plus 32 divided by 2, which is 62 over 2, and that gives 31. The next is to find the mode. Now to find the mode, from the definition of the mode, it means the most occurrence. Looking at this, 29 appeared twice and 35 appeared twice. Other values appeared once. So the mode are going to be 29 and 35. And from the previous video I did, I told you when you have two modes, this is the same thing as bimodal. The fourth one is to find the range. From the definition of the range, which is the same thing as the maximum value minus the minimum value. So here, the maximum value is 40, the minimum value is 24. So the range of the distribution is going to be 16. And the last question is, what is the shape of the distribution? Looking at this, my mean is 31.7, and it is greater than the median, which is 31. If they're approximately the same, then it can be symmetric. But if you approximate this, this is approximately 32, which is greater than 31. Then I can say that this is slightly skewed to the right. So this is slightly skewed to the right. And here, in the next slide, we have that. Yeah, the next is the measures of position. Here, I'm going to be talking about the z-score. The purpose of the z-score is to tell us how many standard deviation data point is from the mean. So in the next video, I'll be talking more about the z-score. But here, we have the quartiles and the interquartile range. The IQR stands for the interquartile range. So the quartiles divide the data into 4 equal parts. Here we have the lower quartile, we have the upper quartile, and we have the median. So those are the things we have. So the median is dividing the entire data set into 2. The lower quartile divide the half of the data into 2, while the upper quartile divide the other half, the upper half of the data into 2. And here we have an example to show how to calculate the quartiles. Now, looking at this data set, the first we want to do is to find the first and the third quartile. Now, to do this, the first thing to do is to rearrange the data set. Yes, this is the first thing to do, because before you work with the quartiles, you need to rearrange the data set. And by rearranging the data set from the minimum to the maximum, we're gonna have we have 5, 6, 5, 6, 6, 7, 7, another 7. Then we have 8, 8, 9, 9, 10, 10, another 10. Then we have 11, 12, 12, 13, 14, another 14, 15, and then here we have 16, 17, 18, 19, and lastly we have 27. So the question is, find the first and the third quartile. Now, for the first quartile, to do that, you have to divide the data set into 2. Everything is 25. You divide the data set into 2, leaving out the median. So if you do that, the median is this 10. This is the median. You leave out the median. So you divide the data set into 2. This is the first half. This is 12 in total. And you have the other half of the data, which is from 11 down to 27. This is the other half of the data. Now, to get the first quartile, it means you find the median of this. And the median of this is going to be 7 and 8. These are the middle number, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is half. Half of 12 is the 6th value and the 7th value. So if you take the average of that, this should be 7 plus 8 over 2, which is 7.5. So the first quartile is represented as Q1. This is the same thing as the first quartile, equals 7.5. Secondly, we have the third quartile is represented as Q3. So you look at the other half of the data. What is the middle value? It's going to be the 6th and the 7th value, which is 1, 2, 3, 4, 5, 6, 7. These are the middle values. And the half of this, if you take the average of this, is 14 plus 15 over 2, which gives 14.5. So this should be 14.5. So now we've gotten the Q1, we've gotten the Q3. And the next question is the interquartile range. The interquartile range is represented as IQR. And the formula is Q3 minus Q1, which is the same thing as 14.5 minus 7.5. And that gives 7. Next, find the lower and upper outlier boundaries. I think these questions was repeated twice. Find the lower and the upper outlier boundary. For the lower outlier boundary, I'm going to use LOB. The formula is Q1 minus 1.5 I QR. And this is Q1, which is 7.5 minus 1.5 multiplied by the interquartile range, which is 7. So this gives -3. And for the upper outlier boundary, I'm going to use UOB, upper outlier boundary. The formula is Q3 plus 1.5 multiplied by the interquartile range. And Q3 is 14.5 plus 1.5 multiplied by 7. And this gives 25. So the lower outlier boundary is -3 and the upper outlier boundary is 27. The last question is list all the values that are classified as outliers or extreme values. You see, the outlier are values above the LOB. So the values above the UOB or values below the LOB. Now, for the LOB, do we have any value below it from the data set? Do we have any negative values? If you check this, no. There's no value less than -3. And for the UOB, do we have any values? This should be 25. Do we have any values greater than 25? Yes. And what is the value? We have 27 to be greater. So the outlier is going to be 27. And choosing the right measure. For your data type, we have different measures are appropriate. It can be continuous or categorical. And for the data distribution, skewness and outliers can influence the choice of measure. And lastly,